Hi, so I'm going to make a couple of videos of short videos of some examples. Some of them have to do with questions that a couple of students have asked in a similar problem or in a different setting, but basically the same idea. The first one is going to be a quotient rule problem, probably from we saw this a couple of weeks ago or last week. So the quotient rule is something that's very important to get used to. It's how to find the derivative of a function that has two functions, one in the bottom and one in the bottom. So I'm going to write, like if you have the derivative, if you want to find the derivative of a fraction f over g, so I'm thinking that both f and g are functions, right, of x. We talked a little bit last week on the video from last week what happens if one of them is not. We really don't need the quotient rule if the top is a constant or the bottom is a constant. Of course, you don't. So in the problem where, on the situation where both are functions, the quotient rule says to do, there's a rule that you have to follow. And we can derive this from the other rules, but I'm not going to do that. We do that in an in-person class, so just use that. So the denominator is the denominator squared. So this is the denominator squared. And then you have to do the derivative of the top times the bottom minus the derivative of the bottom times the top. So I actually write it like this, the same order. Okay, and all over the denominator squared. So it looks kind of like the product rule on the top, but this one has a negative here in between them, and you have to be very careful with this. The order is important, right? This is minus here, and in the first term, take the derivative of the top, and in the second term, take the derivative of the bottom. If you saw the video from last week, you probably saw how this is a little bit of why the negative shows up. So in any case, let me do a small example. So an example that I found interesting, somebody asked me sorry, I'm doing this example not because it's interesting, just because somebody asked me on an email, is to find the derivative of this function. So it's 8x, something like 8x minus plus 5 in the top, and something like a square root in the bottom. It has something like square root of x, I think. So I want to take the derivative of that, of this function. Following the rule, I took the denominator of the bottom, which is just the square root of x squared. There's no derivative here. This denominator just says, the quotient rule just says to use, let me zoom in, there you go. So this quotient rule just says to use this denominator squared. So there's nothing here, there's no derivative, just goes to the denominator squared. So just do that in here then. I'm going to zoom in over here. I'm going to zoom in, so this just because I had the square root of x squared, so I can just do x, right? So this is just x, because I'm going to have the square root of x, but then I'm going to square it, so it's just x, correct? So let me just undo a couple of steps here. It just becomes that. Okay, that's the denominator. Now the top becomes, I'm going to write this down carefully just so you have some. I'm going to do 8x plus x. I'm going to write the steps carefully, because this is my first example. The derivative of the top times the bottom minus the top times the derivative of the bottom. The derivative of the bottom is going to be, I like to always write these guys like powers, right? So if the power, it's like this, it's to the, there you go, that's what I want. So I wrote, always I like to use, I think it's most textbooks use, write as much as you can, write powers, because the power rules are the easiest. Okay, so I'm going to find the derivative of the first part. It's pretty straightforward, right? The derivative of 8x plus 5 is just an 8. So you're multiplying that times the root of x. Then the derivative of x to the 1/2. So let me write the first part. This stays like 8x plus 5 here. The derivative of x to the 1/2. If you want to do it on the side, if you do x to the 1/2 derivative, it's 1/2 x to the negative 1/2. Okay, so that becomes 1/2 times root of x in the bottom, right? You can write it like that. And then all of that is over x squared. So something happened where we have something, for example, another video, I told you guys when you did a difference quotient that had something divided by a fraction looked kind of weird, and maybe you didn't want to see it that way. So something I'm going to do is also rewrite this guy, like just to make it a little bit easier visually. If I write this like 1 over x in front times 8 root of x minus minus 1/2 of root of x times 8x plus 5. So I don't know if this is too much writing, but for some of you this might make things a little bit easier. Again, the trick of writing this x times the number like a fraction in front helps a little bit. Okay. And now what I'm going to do now to simplify, so this is the right answer. It's just the problem that some of you probably are encountering is that you're doing an online book, and this happens even in the real in-class person where in person class where you have to check your answer with the back of the book, and the back of the book doesn't have like this. This is sorry, I'm missing an x here, right? It has an 8x. I'm missing an x in here. This is not simplified, right? If you do your answer like that in an exam, well, I might give you full credit, I might give you partial credit. It's not simplified. This is not the way you would have it. You basically use the rule and you stop, right? So you show me that you know how to find the quotient rule and you don't know how to simplify this. So this is, you have to keep working and make this look a little bit nicer. So so one more step is to simplify this. So there's many ways to do it. I'm going to leave this 1 over x in the front like this, and this big parentheses, I want to write this like in the same denominator, which is the root of x, right? And then I'm going to have if this one had if this one had 8 root of x before, I need to write times that denominator. So I'm going to write I need to multiply top and bottom by this root of x again, right? Because that way it's the same denominator. This one had a 1 before. This had the amount of weight, so I also want to make this. Oh, sorry. In fact, I need to have a 2 root of x, right? So if I want the denominator to be 2 root of x, I need to multiply this by 2. So let me write this. I want the number to be, let me erase this, and I want this to be 2 root of x, because the denominator was 1 before, and my common denominator is really 2 root of x. Okay, and now I do minus 8x plus 5, and I don't need parentheses if I write like this, correct? Okay, so this looks a little bit nicer. We're getting closer to the end. I'm going to write over here because my space is limited. So I have 1 over x outside of that parentheses. And now inside the parentheses, this is just 8x. Right, sorry, this is 16x because I have the 2. So this is 16x. And then I have minus 8x minus 5. Okay, and all that is over 2 root of x. There you go. And now I'm done, because now all I have to do is simplify the inside of this, and I get the 1 over x, if you want to think about it, is outside. 16x minus 8x, you have positive 8x minus 5 over 2 root of x, and that's the answer the book has, or the answer that you would see in the back of the book, or the answer key or something. It would have 8x minus 5 over 2x to the 3/2, or maybe it has like x times root of x. So yeah, so my point is, if you in the exam or quiz leave an answer like this and you stop at this level, if you stop right here, you're getting the right answer, right? If you stop at this stage, that's the correct answer, but I might give you, I don't know, 8 out of 10 points, or isn't like you did the right steps, but you're not simplified. And if you go make it to this level down here, then you get full points, and you get the 10 out of 10 points for that problem. Okay, so if you don't simplify, you'll still get a great grade, but you're not doing all the work, and so you're not get the full extent of the grade. Okay, so just don't be scared using all the algebra you learn. That's why a calculus class is after you took all these algebra classes, because there's lots of algebra that you need to work on, and many times what's hard about a calculus class is not the calculus itself. Those rules are pretty simple once you get used to them. Sometimes people get to this stage very easily, but they have a problem getting to this stop, right? And that's just algebra. I know the word "just" is just like it doesn't sound nice to you guys right now, but it's just algebra. Okay, sorry. Okay, well, I'll make another video short. Bye.